VIA-based virtual assembly technology has been developed to address the problems of small batch sizes, multiple models, complex assembly processes, and high accuracy requirements for aircraft component assembly products. Scientists from WiMi Hologram Academy of WiMi Hologram Cloud discussed in detail the research and application of virtual reality in aircraft component assembly process technology. Before the product is manufactured, technical workers need to plan the product assembly sequence and path, select fixtures and operation methods in the virtual environment, verify the rationality of the assembly process design, and discover various design defects, structural interference and other problems in the process in a timely manner. Thus, technical workers can visually and scientifically analyze the operability, visibility and accessibility of the assembly object. Then, according to the virtual simulation, modify and optimize the process method, tooling structure and production line layout, etc. Finally, it generates a scientific and reasonable product assembly process plan to shorten the assembly cycle, reduce the assembly cost and improve the quality of component assembly. Aircraft component assembly accounts for a large percentage of the overall aircraft manufacturing process and is a comprehensive and integrated technology involving multiple disciplines. This technology is closely related to product quality, production cycle time and manufacturing cost. The use of VIA-based process assembly technology can identify aircraft design and process problems in a timely manner, solve existing problems as early as possible, shorten the product development cycle, and thus reduce product manufacturing costs. The technology is based on a virtual reality platform, with CAD software numerical models as input conditions, computer virtual simulation as technical support, and desktop or immersive virtual environments as implementation paths, which can realistically simulate the product assembly process through CAD modeling, virtual assembly process design simulation, and process documentation generation and demonstration, thus enabling the detection of assembly problems and thus avoiding design defects. However, the human-machine interface with a 2D monitor, keyboard and mouse as the main interaction tools, as well as CAD software movement, scaling and rotation commands have limitations in simulation, which affects the further development of the technology. The immersive virtual environment, however, manages the product model directly through 3D operations, complete with the process of assembly and 3D paths, improving this technology and thus gaining widespread use. In the mid-1990s, researchers conducted preliminary research on virtual assembly technology, proposing the use of virtual reality software and hardware to provide virtual scenarios with immersion, interactivity, realism, and ease of operation for assembly process technology. With the increase of support from relevant countries and industrial information technology departments, they have achieved many research results and have been well applied and promoted. The domestic research mainly stays in the desktop virtual assembly stage, through the supporting virtual simulation analysis to check all kinds of design and process problems, and finally get a scientific and systematic product assembly planning. Data layer. The data information in the system, such as viewing permission, use and modification permission, approval and submission process, etc. Product planning and design information, mainly including the geometric position relationship between parts in the assembly process, assembly order, constraint relationship, assembly path, process structure description, etc. VIA-based aircraft assembly process technology mainly refers to the use of virtual reality technology to establish a highly realistic and immersive interactive assembly environment. This assembly environment is centered on the assembly process designer, according to the corresponding knowledge and experience. The designer establishes the assembly sequence and 3D assembly path of the product parts in the computer through CAD numerical models. And the assembly imitation layer mainly includes the geometric model information of product parts, geometric model information of tooling and tooling, software system management data information and product process planning and design information. The geometric models of parts, tooling and tools are mainly from CATIA software, including the geometric information, attributes and interrelationships of the products. The software system management data mainly stores the product-related management virtual assembly environment establishment, assembly process design, and simulation analysis results output. The virtual assembly environment is established by first locating the products and resources in the simulation environment, and then setting the attributes for the imported models, such as the dynamic properties of the products, collision ability, Interference properties and dissolution compensation. The assembly process design includes assembly sequence planning, assembly path setting, collision and interference checking, establishment of geometric object constraints, disassembly simulation with tolerances and ergonomic analysis and optimization, etc. The virtual assembly system can record the assembly simulation results in real time and output them in the form of process documents and 3D simulation animations, according to the simulation process to determine the scientific and reasonable assembly sequence. 3D assembly path can be used as a reference and guide for the actual work. The output of simulation analysis results mainly includes process catalog generation, process protocol reference files, human-machine interaction simulation results, product interference and design defects, and assembly demonstration files. Support layer. The virtual reality environment is supported by the hardware for virtual assembly process design planning and centered on the process operator to realize the information exchange and interactive operation of assembly process design in the immersive environment. This function is mainly through inputting virtual operation instructions and parameters, calling the corresponding processing module of the application layer for processing, and realizing virtual roaming of the scene, so that the system has an intuitive and realistic human-computer interaction interface. Digital model virtualization, visualization and operation environment virtualization, and human-computer interaction operation process virtualization are the three main aspects of the assembly process virtualization. In the virtual 3D environment, the process personnel can perform the same virtualized operation as the actual assembly process through the digital model resources provided by CAD. The implementation object, operation process and assembly resources used in the virtual assembly process design are highly compatible with the actual production, thus reflecting the real process of product assembly vividly and intuitively, and making the simulation results highly credible. The main difference between desktop-style 3D static assembly and VR-based virtual assembly is reflected in the human-computer interaction. With the help of the main equipment of VR, such as data suits, data helmets and gloves, 3D operating mice, etc., the craftsman is able to complete the movement, rotation, grasping, installation and disassembly of parts in a virtual scene similar to the actual working environment. The operator is truly involved in the assembly process, reflecting the subjective intent and thoughts of the person, making full use of the assembly experience and knowledge acquired, and realizing the human-centered process design. The virtual assembly process is the transition stage between upstream and downstream of product design and manufacturing, and is an important link in the product life cycle. The process guarantees the integration of information in the design and manufacturing, quality inspection and operation management of the product. The 3D digital model of the design process, the digital model of the tooling needed for the manufacturing process, the digital model of the automated equipment used in the process, and the process model obtained using process division and simulation technology, form a unification in the whole process. The virtual assembly process realizes both the transformation of the physical model to the 3D digital model and the planning, analysis and simulation, and optimization of the assembly process in the virtual environment. The virtual assembly process is closely connected to all parts of the product chain. Traditional assembly simulation interaction is simple and can only operate on the geometric model of the part through 2D input and output devices, mouse, keyboard and flat screen display, etc., and the efficiency of assembly planning is low. The assembly simulation in virtual reality environment is fully supported by immersive display system and spatial interaction devices to realize the first perspective of the craftsman's casual observation and operation, simulate the real working process, realize the movement, rotation and scaling in 3D space quickly and accurately, and can get real feedback to enhance the interactive experience and quickly discover the assembly problems exposed in different perspectives. Most assembly simulation ideas are the inverse process of disassembly and assembly. The way is to quickly get the product assembly sequence by planning the disassembly sequence of the assembly model. But the assembly order and disassembly order are not completely reversible process. So the obtained assembly order can only be used as a reference. And the virtual reality environment has its own advantages for the installation, operation and positioning of the product. And it can carry out simulation verification of the installation process and path recording for this sequence. In response to the practical problems and needs of aircraft component assembly process planning, design and production, This paper has carried out the work of combing the architecture of the assembly process technology under the virtual reality environment. The paper focuses on the characteristics and advantages of this technology over traditional practices and existing assembly simulations, and uses this technology to make practical applications in the production of aircraft component parts, which plays a key role. However, there is still a long way to go before this technology can be used in a mature, systematic and widespread way. In the future, we should focus on the problem of differentiation between virtual assembly theory and actual production. In other words, the practicality of virtual assembly, the problem of data display form of virtual assembly object model. In other words, solving the accuracy level of the model triangular surface piece, and carrying out virtual simulation of flexible pipelines in the field of aircraft assembly. With the development of VIA technology and assembly process technology, virtual simulation technology will be able to truly play the role of guiding production and solving problems.